All right, I wanted to do a walkthrough through a case study with you today. In this case, I wanted to show you this allosteric pan-mutant-selective PI3K alpha inhibitor that doesn't display any hyperglycemia in preclinical models and also not in clinical studies. What we will do is we'll give you the name of the compound, an executive summary of where the molecule currently is, how it was discovered, by whom it was discovered. We'll give you the structure here in this top paragraph as well. Then we'll talk about why you should be reading about this molecule and how does it fit in the context of other PI3K alpha inhibitors, in this case, such as alpelisib and inavolisib. So we'll talk about what is so significant about this molecule, and we'll later get into this hyperglycemia effect that I already mentioned in the beginning and why this is so important. We'll talk about what this is tested for in clinical studies. So here for HR positive and HER2 negative breast cancer in combination as well as a single agent. And currently, the efficacy profile remains to be seen whether or not the efficacy is superior. Currently, it looks like it's on par with alpelisib and inavolisib, but the target engagement that is seen in human and the safety profile is really encouraging. So we'll give you a comparison here with the biochemical IC50 data and the selectivity data of wild type over mutant. And what you can quickly see is that both the Scorpion compound, which is also an allosteric inhibitor of PI3K, as well as the compound that we're talking about here from Relay Therapeutics, also an allosteric inhibitor, are really way more selective over the wild type PI3 kinase. We'll talk about why PI3 kinase is actually a target in oncology. It's a lipid kinase, of course, that's a well established driver in cancer due to its high mutation rate in specific cancers such as breast, bladder, and colorectal cancer, for example. And those mutations typically occur in the helical domain as well as in the kinase domain. Wild type PI3 kinase is actually known to block insulin action. So by blocking PI3 kinase, insulin action is blocked, which then prevents the uptake of glucose via specific GLUT transporter that leads to breakdown of glycogen in the liver, which ultimately then leads to hyperglycemia. We talk about how this compound was discovered. So here, this compound was actually discovered in a DELT screen where three things were ensured. So first, basically full-length wild type and mutant constructs were compared to preserve the allosteric network. Second, the orthosteric side was actually blocked in order to increase the chances of discovering an allosteric modulator. And third, they looked for particular high activity on the mutant PI3 kinase over the wild type. And those efforts led to compound 1 here, which basically they quickly elaborated with a heavy atom such as bromine. Then they could do a co-crystal structure with the mutant. We highlight where these, if there are any potential hydrogen bonds or hydrophobic interactions with this molecule. They quickly discovered that this aminopyridine here can be modified and can basically be switched to this isoindolinone core, where a higher selectivity and an improved potency profile were observed. And then they essentially quickly elaborated this to this triazolopyridine here, which then ultimately was the clinical candidate with really high selectivity of mutant over wild type. We talk about the binding mode here and compare the competitor compound from Scorpion Therapeutics. We talk about how the selectivity is driven, which is in this case really interesting because it's a kinetically driven selectivity, meaning that with this particular compound, they saw a 10-fold faster on rate and a 1.4 slower off rate, which ultimately led to higher target residence times of the compound on the mutant over the wild type. And that's an interesting phenomenon that Relay Therapeutics has been seen with their other FGFR2 inhibitor that they have in the clinic. So we talk a little bit about preclinical models here. So they did see efficacy in a preclinical HR positive breast cancer model. And what they also saw is that basically the insulin elevation was not observed. So that basically proved to the point that potentially hyperglycemia was not an issue with this particular compound. And in fact, in the clinical studies, in the phase 1 trial, they did see no events of grade 3 or grade 4 hyperglycemia with their compound, whereas pellicip uh, combined with an ER degrader and inavolisib actually did see a number of events in this category. We talk about the route in the end. So in this case, we highlight the medicinal chemistry route, which here interestingly features the Passerini 3-component reaction with this acid, aldehyde, and isocyanide here to build this building block, and ultimately with a Suzuki coupling, stitch up the final candidate. So yeah, that's just one example of our case studies that I wanted to show to you today. I hope you really enjoyed this, and let me know what you'd like to hear more of.